So we're going to calculate the improper integral from 4 to infinity of dx over x to the 3 halves. And first thing we do is we rewrite it as a proper integral. So we're going to go from 4 to, let's say, b. I'm going to write this as x to the minus 3 halves because it is going to involve taking the antiderivative. And then to handle the infinite limit, we're going to do the limit as b goes to infinity. So we have a pretty easy power rule here. So we get limit as b goes to infinity. This is going to be, and we're going to increase the exponent by 1. That's going to become x to the negative 1/2 divided by the new exponent. And we're going to have to put in those limits before we take the limit. Using that word two different ways, I know it can be confusing. So if we want, we take the reciprocal. I can actually write that -2 out front. Now remember, with the -2, that's 1 divided by negative 1/2. So you flip and multiply. We get the limit as b goes to infinity of x to the minus 1/2 from 4 to b. So we have -2 limit as b goes to infinity of, if you want, you could write this as 1 over the square root of b minus 1 over the square root of 4. Now, here's the big part. This is just a number. What happens as b gets infinitely large? Well, the reason I wrote it back in the denominator was to make it obvious. The denominator is going to grow, the numerator is going to stay the same size, therefore this guy here is going to go to 0. 1 over square root of 4 is 1/2, so we end up with -2 times -1/2, or that this guy converges to 1. So we could just say converges to 1, or it's convergent with the value being 1.